Okay, so now I move my laptop to the table so I can show the module details for you. And now you can see there's a light there, and that's the appliance that I'm going to control using the module. And let me see if I can show you the module. Okay, this I cannot take it near to the camera because it's all mounted with the cables and the wires there. So you can roughly see there's two modules here. And here, this is my controller here. And I'm going to plug the USB OTG on my Android smartphone. And on the other side of the cable is the FT232L RL device that is compatible with this application. And on the other side, this is the UART telephone. And now I'm connecting it to the SCM frequency. And now I reset the controller here. And I'll later show you the details, a near video about on the board here. And again, because I'm using my smartphone to control the circuit, so I cannot use the camera on it to shoot this video, so I'm holding the laptop on my shoulder and just want to show you about the module. And this is the two module, and the terminal strip here, black blocks here are the terminal end that you can put any kind of appliance or anything you want to connect by a switch through these terminals. And now you can see there's a red and another gold terminal already connected to it, because I have already made the cables of the light adapted from the wall power socket to the board, and now already waiting for the switch on to happen. So I'm going to turn off the light to show you the details. And this is the LED for the second relay. And this is the first relay for the first relay, and you can see that clearly in the darkness. Okay, it's very dark here, and I'm going to turn off my monitor on the back because it's too bright. And I move the camera, and this is not a good cam, so In the dark, it is a lot of noise there. And now this is the control panel. Again, it's too bright. And I've already turned on the power for the relay module 13.2 volts to drive the relay. And the circuit is already built to be compatible with a 3.3 volt or 5 volts logic level high to turn on the relays. And therefore the STM32 will work. I reset the STM. I'll turn on the second relay first. Oh, I'm not connecting the USB now. Connect the USB, and it's now connected. So when I tap on it, the second relay will gradually turn on, and the LED will gradually light up. Oh, it's too bright, and you can hear that the click of the switch of the relay. And you can see there's a red light on the board of the controller. It indicates that the relay 2 signal, that the string is received and is valid to turn on relay 2. And when I tap the relay 2 button again, relay 2 will turn off. And when I turn on relay 1 will instantly turn on. And the difference between these two relays is just the timing functions. The relay 1 doesn't have the timing, it turns on instantly. And for relay 2, I designed a RC timing constant for the turn on process. When the RC reaches enough level voltage, the coils of the relay 2 will gradually build up the magnetic field and turn on the relay. This reason is why it is that some amplifiers have the output relay turn on, so it can time for a couple of seconds to turn on to prevent the start-up pump or dump voltage that will cause the speakers to be damaged. So that's the reason I would design these functions. And it is also functional with other appliances, not only for amplifiers. Just for something you want to turn on later, to delay for a couple of seconds to turn on, to prevent something you don't want at the beginning of the system startup. So again, I'm tapping relay 1. Relay 1 will turn on. The LED is very bright. And on relay 2 will gradually turn on. It's not turning on now. Oh, because the LED is dropped off. Let me fix that. Okay, relay 2. Okay, relay 2. Turn off. Relay 2 gradually turn on for 3 seconds roughly. And relay 1 instantly turn on. And now I'm going to connect the light, so you can see a very bright light turning on and turning off. Okay, I'm just checking on the table the darkness that to make sure that the high voltage doesn't contact with each other, to make sure everything is safe. And now I think this is not a very good demo because the socket output, the wall output, the 110 volts AC is just barely hanging around on the table, so that's not very safe experiment. Okay, so now I'm turning on relay 2, but because relay 2 isn't connected to anything, so it just turn on and nothing happens. And for relay 1, when I tap on the relay 1, you can see the light turning on, and also the relay 1 is, the LED is very bright. You can see the brightness that is shot on the oscilloscope and the power supply. And again, when I tap off, the light will turn off. So with this functionality, you can control anything you want to switch on, switch off, and not just for a light. And I think there are some other applications for Android to control the OTG device, but I think this one is the best because it has GUI and you can create buttons and some actions like sending a string or ST or some protocol specific settings. So this is very good application, and it's freeware, so you can download it USB control panel. And that's all for this demo. And see if I can demo something else. Not now. And there's some wireless power studies besides. Turn on the light. Turn on the light because the signal is stopped. There are something about wireless powers here on the table, and maybe later I will shoot another video about that and explain the controlling methods for the regulation of the wireless power supply. And that's all for this video.